Alright, in this video we're going to go over your Chapter 9 Geometric Sequences and Series Quiz Review. Number 1 says, consider the geometric sequence. Find what is the 15th term. Alright, so over here, here's our formula. A sub n equals a sub 1 times r raised to the n minus 1. So a sub 15 is going to equal our first term, which is negative 4, times our ratio. Well, you get your ratio by picking one term, dividing it by the term before it, so our ratio is negative 3 over 4, times 15 minus 1. Alright? So you're simply just going to punch that into your calculator, and you're going to have negative 4 times negative 3 divided by 4 raised to the 14th. So your answer is going to be a fairly small number. It's going to be negative 0.0713. So it's going to be a fairly small number. All right. Or the fraction just looks ridiculous. The fraction is negative 4782969 over 6710884. So if you got this, you're still right. That's just the decimal form of that. Alright? Let's look at number 2. It says, consider the partially completed geometric series and fill in the blanks. So let's consider the partially completed geometric series. We have 3/5 as our second term. We don't know our third or our fourth term. We have negative 81 over 625. So what you want to do here, first thing we want to do is we want to find our ratio. We need to find that first, because then once we can find our ratio, we can do this really easily. So what you want to do, take the first term you have, that's 3/5. We know that 3/5 times r times r times r, we know that's going to equal negative 81 over 625. So this is 3/5 times r cubed equals negative 81 over 625. So we're going to multiply both sides by 5/3 to get r cubed by itself. This goes to 125. This goes to 1. This goes to 1. This goes to 27. Alright, so r cubed equals negative 27 over 125. Take the cubed root of both. So r equals negative 3/5. Alright, now that we have r, we can simply multiply r by 3/5. So 3/5 times negative 3/5 is negative 9 over 25. Multiplied again, 9 times 3 is 27. 25 times 3 is 125. Now going back, we can divide it or multiply by the reciprocal. So we're going to get a negative 1. Because 3/5 divided by negative 3/5 is the same thing as multiplying by negative 5/3. Everything cross cancels, and and don't forget the negative, you're left with negative 1. So there's your missing terms. You got to find out your ratio by taking the first number you have, put in the appropriate number of r's for the number of hops, equals the last term you have, and then we just simply solve for r. Alright? Number 3, we have another partial geometric series, and we want to find the sum of, I believe, the first 15 terms. So we have 1, 2/3, 4/9, and so on. So we want the sum of the first 15 terms. So we're going to use our sum formula, which is a1, a sub 1, times 1 minus r to the n over 1 minus r. So our sum equals our first term, which is 1, times 1 minus r. Well, remember, you take 2/3 and you can divide it by the previous term, so it's just 2/3. Raised to 15 over 1 minus 2/3. Now this is simply a calculator problem. Plug that into the calculator, and for number 3, you should get 2.993. Do not round this up to 3. Give me enough decimal places that you do not have to round this up to 3. I would not take 3 as the correct answer for this problem. All right, because it's not. It's 2.993. So don't round it up to 3. Number 4. We have sigma, so we're finding the sum. And just erase the sum formula. Well, you have it on your paper too. Alright, so number 4. We want to find the sum of this. J equals 1 to 11. Negative 2, 1, 8 times j. You plug in the 1, because we need to find our first term. Because it's a sub 1, 1 minus r to the n over 1 minus r. That's an n. That equals our sum. So all we need to do here is find our first term. Plug in 1. 1/8 raised to 1 is 1/8. So negative 2 times 1/8 equals 1, 4, negative 1/4. That's our first term. So S equals negative 1/4 times 1 minus r. Our r, remember, it's what's inside the parentheses, raised to j, is 1/8 raised to, how many terms we have? Well, 11 minus 1 is 10, plus 1 is 11, over 1 minus 1/8. Again, straight calculator problem. Punch it in, and you should get negative 0.2857. Again, do not round this. Do not round this to like 0.29 or something, 0.29. Give me at least 3 or 4 decimal places. If you have to go further so it doesn't round to like 1 or 0, give me enough decimal places so it does not round. All right? Number 5 works the same exact way. I'll leave the sum formula this time. Number 5. Actually, it doesn't work the same exact way. J equals 1 to infinity, because this is now an infinite series. So our sum formula changes from this to the sum of an infinite series equals the first term over 1 minus your ratio. So again, we've got to find our first term. Plug in 1, 2/7 raised to 1 is 2/7. So a sub 1 is simply 5 times 2 over 7, which is 10 over 7. Our ratio is 2/7. So now you just plug it in. So we have 10 over 7 divided by 1 minus 2 over 7. So 10 over 7 over, 5/7. You can flip this out. 7 over 5. So it equals 2. 5 equals 2. Alright. All I did there was I just did the math by hand. I didn't use a calculator. 10/7 divided by 5/7, because that's what 1 minus 2/7 is. Remember, when you divide fractions, you can take the bottom one, flip it out, take the reciprocal, multiply it. And then, of course, you can cross-cancel. The 7's cancel to both 1's. The 10 and the 5 go to a 2 and a 1. 2 times 1 is 2. 1 times 1 is 1. So the answer is simply 2. Alright? Let's look at number 6. Number 6 is just like number 5. Uses the same exact formula. We just have different numbers. So we have j equals 1 to infinity of negative 1 times 7/9 raised to j. Plug in the 1. So of course here our first term is just negative 7/9. So we come over to here. Apparently I'm not moving enough to keep the light on. So we come over here. Our first term, negative 7/9. 1 minus our ratio, which is 7/9. So this is negative 7/9 over 2/9. Flip it out. Times 9 over 2. The 9's cancel. So this is negative 7 over 2, which is negative 3.5. I'll take either one, the decimal or the fraction. I'll take negative 7/2 or negative 3.5. I hope you can see that. Negative 7/2 or I'll take negative 3.5. All right. Number 7. Find the sum of the following infinite geometric series. Since it's infinite, we're using this formula yet again. Y'all really remember this formula by the time we get done. Alright, so we want the sum. Negative 1, negative 1/3, negative 1/9, ... So our first term is negative 1. 1 minus our ratio. What are we doing each time? Well, take one term, negative 1/3, divided by the term before it, negative 1. Negative divided by negative is a positive. Anything divided by 1 is itself. So we have positive 1/3 is the ratio. Negative 1 divided by 2/3 times 3/2, negative 3/2. Alright, or negative 1.5. Again, I don't know if you can see that. This is not the answer. Again, I don't know if you can see that. So the answer, I'll either take negative 3/2 or I'll take negative 1.5. I'll take either one of those. Alright, so that's how you do number 7. Number 8. You're the winner of the Not So Lucky Lottery. Well, you will receive 3,904.21. It's hard to say that in there. Pennies on the first day. Then after that, you will receive exactly 3/4 the amount of the previous day's pennies. How many pennies will you have after 19 days? All right, so we're finding the sum of a finite series. Sum of a finite series equals a sub 1 times 1 minus r to the n over 1 minus r. So, a sub 1 is that ridiculously large number of pennies. So 3, 9, 7, 4, 2, 1. 1 minus our ratio. What's our ratio? 3/4. They gave it to us. 3/4 raised to the n. The n is 19 in this case because it's over 19 days. Minus 1 over r. Alright. Calculator problem. Plug this into your calculator. And you will have 1,582,962 pennies. Now, here, there is no need to give me a decimal. Because it says, how many pennies will you have? Whoops. Did I write that wrong? No, I did. So, how many pennies will you have? Well, you can't have a decimal. If you did the decimal, it would be 0.37, but you can't have 0.37 of a penny. So, that would round down just to the 962, all right? So, again, here, no need to give me a decimal. Just make it pennies. So, you'll have almost 1.6 million pennies. That's a lot of pennies. All right, and if you think about it, it's only $15,000. Well, I say only, that's not a lot of money. That is to me. I don't know about to y'all, but... All right, so there's your Chapter 9 test review. Feel free to watch this as many times as you need to. Make sure when you come to class tomorrow, you're ready to take your exam. See you tomorrow.